Okay, let's continue working our way through the section on the method of partial fractions. And in each one of these problems, we're just going to kick up the difficulty just a smidge. So here's our new problem. So evaluate the integral of x squared over x minus 3 times x plus 2 squared. So let's see how we're doing. The degree of the numerator is smaller than the degree of the denominator. That works. The degree of the numerator is 2. And 1, 2, 3 here for the degree of the denominator. But now, the denominator is factoring to linear factors. That's still good. But now there's repeats. So this is going to be a little bit trickier. There's a little bit different method that we have to use here. So as it turns out, we definitely can still come up with a partial fractions decomposition for this rational function. It just is going to look a little bit different. And how it looks is, so for x minus 3, that's one of the terms in our denominator. That's going to be treated just as before. There's some constant a. We're going to have a term in our partial fraction decomposition that's just a constant a divided by x minus 3. Now, if that squared wasn't there, if this is the problem that we'd be doing, this would be our partial fractions decomposition. But because we have x plus 2 here as squared, we actually have to tack on one more term. Oops. That is supposed to be a 2 there. Downside of markers, I can't erase small mistakes, have to scribble them out. So if we're in this situation, so this is because we have an x plus 2 squared in the denominator. So because we have a factor x plus 2 squared in the denominator, we have to include in our setup both a factor of x plus 2 and a factor of x plus 2 squared. And we can put constants that we'll figure out what they are. B and C, we'll put constants over both of them. So this is the price we pay for having a squared in our denominator. We have to have one of each of these terms. The solving process is going to go through much the same way to figure out what the coefficients here are, A, B, and C. Although, as we see, there is going to be one kind of interesting little twist. Okay, so just as in our previous problem, the first step is going to be clear out the denominators, multiply by x minus 3 times x plus 2 squared. And so that will give us x squared is equal to a times, so x minus 3 and x minus 3 will cancel, times x plus 2 squared, plus b times x minus 3. So b times x minus 3, and we'll cancel out one of the factors of x plus 2, plus c times x minus 3, and now both of the factors of x plus 2 are going to cancel out. So this is the setup that we have. Let me recopy that on the next slide here, and then we'll crunch things out. Okay, so same game as before. We need to figure out what A and B and C are, and we're allowed to substitute in any value of x that we want to. Okay, so what's the easy ones to do here? So as it turns out, two of them are going to be easy for us. One of them is going to be a little bit trickier. So let's start off with the easy ones. We plug in x is equal to 3. These two terms are both going to be 0. And so we have x, 3 squared is 9. is equal to 3 plus 2 squared times a plus 0b plus 0c. And so this is, so we see here 9 is equal to 5 squared, 9 is equal to 25a. So a is equal to 9 over 25. And I said, sometimes fractions are unavoidable when we're working out these partial fractions. Okay, so what else do we have? Well, the other easy case is going to be, if we plug in x is equal to minus 2, these two terms are going to become 0, and then we can figure out what c is. So minus 2 squared is equal to 0 times a plus 0 times b plus minus 2 minus 3 times c. So 4 is equal to minus 5c. So this tells us c is equal to minus 4/5. Okay, so right now we know that x squared is equal to x plus 2 squared times a is 9 over 25 plus x minus 3 times x plus 2 times b plus x minus 3 times c is minus 4/5. Okay, so at the end, we still have to figure out what b is. So let's appreciate here that we've plugged in the two natural things to plug in. That we've plugged in x is equal to minus 2 and x is equal to 3. Those are basically the only things that it really makes sense to plug in. That will make our life easier. Those are the only two things we can plug in, I guess is what I should be saying, to make two of the terms instantly disappear and to easily allow us to solve for a variable. We can't do that to solve for the b. So there's two ways that we can handle things from here to solve for b. Number one is that we could just plug in any other value of x that we want. So for example, we could plug in x is equal to 0, and so we get 0 is equal to 2 squared times 9 over 25 plus minus 3 times 2 times b plus minus 3 times minus 4/5. And that gives you a slightly messy equation to solve, but it's pretty easy to do, just a little bit tedious. However, there's a second method to think about it, and there's a second method to do it, which is comparing coefficients of powers of x. And so the point here is that this equation has to be true for all for any value x we plug in, but it also has to be true in the sense of that this whole thing over here has to be x squared. And so that means that the coefficient, so let me go to a new slide here. The coefficient of x squared on the left has to equal the coefficient of x squared on the right. So what are, that's a horrible looking right. What are those coefficients? So what's the point here? Once again, these two are exactly the same polynomial, so they have to have the same coefficients for the same terms. So the coefficient x squared on the left is 1. And the coefficient of x squared on the right is, so when we expand this out, we get x squared plus 4x plus 4 times 9 over 25. So that's 9 over 25 coming from there. Then 1x times 1x times b. So it's plus b. And there's no x squared there. So that's plus 0. And so we conclude that we have the equation 1 is equal to 9 over 25 plus b is equal to plus 0. So b is 16 over 25, solving for b in that case. Okay, so where are we? We can say now that x squared over x minus 3 times x plus 2 squared is equal to 9 over 25 times x minus 3 plus 16 over 25 times x plus 2 plus minus 4/5 over x plus 2 squared. Okay, so this video's gotten long enough. I'll finish off the problem in the next video.